So question number 2 on page 344 says, find the direction of the missing quantity from magnetic field, velocity, and force, in each case shown in figure 6.22. The circle represents a positive charge. So let's go through each of these and understand what we're looking at, okay? So if this is a positive charge and we have a force pointing to the right and our velocity is pointing down. Now it's really hard to see this, but again, we're thinking of how I set up these types of questions, okay? Is we're gonna use our right hand. So let me see if I can draw this, right? So here's our hand, then we have our thumb pointing in one direction, and then we're gonna have our 4 fingers pointing the other direction, and it's a really awkward looking hand. And so what we have to think about is our thumb is going to point in the direction of our velocity. Our fingers are going to point in the direction of our field. And then our palm, in this case, if this is our right hand, right? If our hand was oriented like that, our palm would be facing out of the page, and that is the direction of our force. And I try to remember it by, if I'm hitchhiking, I'm using my thumb, where am I trying to go? If I'm feeling something, I'm use my fingers, and that's my field. And then if I'm going to smack someone, give them a nice big slap, I'm going to use the palm of my hand to apply that force. So I'm going to try to orient my thumb on I'm using my right hand because this is a positive charge. Okay, so for a negative charge, you'd either use your left hand with the same orientations, or just use the back of your hand for the force instead of the palm. All right, so for this, I'm going to have my thumb pointing toward the bottom of the page. I'm going to have my fingers, I'm going to have my thumb pointing to the bottom, my palm of my hand pointing to the right. And when I do that, my fingers are actually going to be pointing into the page. So magnetic field is going to be into the page in this scenario. All right, so let's look at question number 2, B. So for B, what do we have? We have, again, a positive charge here. We have a velocity now, so that's my thumb pointing to the right. We have a magnetic field, so those are my fingers pointing down. And when I orient my hand like that, it's a really awkward scenario. My force is actually now pointing into the page. So my palm, it's almost like I'm laying my palm on top of the page. My thumb is pointing to the right, my fingers are pointing to the bottom of the page, and my thumb is pointing in. All right, so let's do C. C, we're now going to have, again, a positive charge. So I'm using my right hand, velocity to the left, and a force upward. So that's my palm. Oopsie. So the palm is pointing to the top of the page. My thumb is pointing to the right. So again, an awkward scenario here. And my field would be pointing out of the page in this scenario. For D, we're going to have, again, a positive charge here, magnetic field up, a velocity down, and in this case, this is going to be impossible, right? So if we think about, there's no way I can have my fingers point straight up and my thumb point straight down. A few people can when they have that, double or triple jointed thumb, but for most people, it's going to be impossible for our fingers to point up and our thumb to point straight back down. So in this case, our force is actually 0. And that's because we use the equation F equals QVB, right? And that's sine of theta. And we're going to have an angle of 180 degrees. And so the sine of 180 is going to go to 0. So that's why our force in this case would be 0 as well. All right. Lastly, let's finish up with E. E is going to look at a positive charge. We're going to have a magnetic field and our velocity. And in this case, just like we talked about before, it's actually going to be impossible for our thumb Just like it's impossible for our thumb to point in the opposite direction of our magnetic field, it's actually not impossible to have our hand oriented like that, but when we're doing the right-hand rule, we always need to have our thumb perpendicular to our magnetic field. So in this case, our force, again, is going to equal 0. And that's, again, we're going to use this equation here to prove that. And the sine of 0 degrees, the sine of 0 degrees, let's write this, is 0. And so there's going to be no force at E as well. Okay, so in these scenarios, A, B, and C all have a force acting or a magnetic field, whereas D and E both have a force of 0.